All right, let's take a look at the answers to the rest of these. So if MPC is equal to 2, then the multiplier would be equal to, let's change colors here, 1 divided by 0.8, and that would be equal to 1.2 for the multiplier. If the MPS were equal to 9, it would be 1 divided by, it's just going to be 0.9 in that case, and that's 1.11. And if the MPS equal just 1, have 1 over 0.1, and in that case the multiplier would be 10. That brings me to this question here. As MPS is getting larger, the spending multiplier gets what? Smaller. So in other words, the more money that gets taken out in each round, the smaller the effect of the multiplier. And why is that? Well, because the money that's removed from savings in one round cannot become spending in the next. All right, so now that we know how to calculate multipliers, we need to know how to use them. So we're going to fine-tune fiscal policy using the multiplier effect. What we've done in the past is basically say, hey, if we're below potential output, we're going to increase government spending to increase aggregate demand. But realistically, the President and the Congress aren't presented with a choice of just increasing government spending. They have to decide how much to increase government spending by. So let's take a look at the example here. Suppose that we figure that we are about $500 billion below potential GDP, meaning that the economy is going to be in a recession by about $500 billion. And we also know that the MPC is 0.75. And I'm just going to privately think to myself that that means that MPS must be equal to 0.25. All right, so how much additional spending is needed to reach potential output? So let's set this up. So we have the amount of money that we're going to spend times the multiplier has to equal a total of $500 billion. First, let's calculate the multiplier, and then we can figure out how much spending needs to change by. So the multiplier is just going to equal 1 over MPS, which is equal to 1 over 0.25, which equals 4. So we know that we have to spend, or we know that for every dollar we spend, there's a total of $4 change in aggregate demand. So that means if we just take, so the multiplier is 4 times that mystery number equals 500. At that point, it's just a matter of solving for x in this case. So we would have to increase our spending by how much? 125, don't forget, talking about $1 billion, not just single dollars. All right, so in this case, because the multiplier is equal to 4, we would spend $125 billion initially, but that would move AD by the full $500 billion and bring us back to potential output.